Hello, I am Catherine Baylis. My topic is Propeller Clock. Definition: it is a digital clock created with the help of the Arduino platform that has a code that allows the legs to light up a certain frequency, using also a motor wave when it turns make the phenomenon of the above. Persisting of vision. When doing this, the leg show the time, the month, and the years. Next video.
This is something a little bit different. This is a demonstration of some basic features of the Arduino programmable microcontroller system. This is an Arduino Uno that I bought at Radio Shack, but it's an open source hardware system, and there are many companies that make clones of the Arduino that are fully hardware and software compatible. So, although this is an original Italian-made Arduino, you can find other ones made by different companies that will do exactly the same things, both in software and hardware. Okay. And the Arduino basically has a microcontroller with memory and some digital outputs and some analog outputs, digital input outputs, a USB port for programming, external power port, and some other ports that are concerned with programming applications way beyond where I'm at. So what I'm going to do with this video here is just to illustrate some basics of reading an analog input and using that analog input to control what's happening on some digital outputs. So I've made 4 or 5 little program sketches to illustrate some of those features. And just for convenience sake, what I've got here is a printed circuit board that matches 12 LEDs with their dropping resistors to some header pins that I can plug in directly to the Arduino. Right there, the right pins. Okay. So now I have an LED plugged into each of 12 of the digital input-output pins of the Arduino, and then on the analog side, I have this 50K potentiometer with the pot itself hooked across the plus 5 volt and the ground leads, and then the wiper hooked to the analog.
Material list: Arduino Pro Mini, 7 green LED, 7 blue LED, 16 red LED, 1 motor, 12 VDC, 1 sensor Hall effect, 1 sensor temperature, terminal and adapter mini USB, power supplied 5 VDC, 1 small PCB board, 1 micropulser, wire for jumper, soldering iron, soldering 1 lactor, and Arduino for coding. Next video. Application Poe effects. This is the phenomenon which is related to vision capability of human eye, by which an after imaging is thought to persist for approximately 1/25 of a second. So, if someone is observing the imaging and accurate of 25 imaging per second, they appear to be continuous. Pros and cons. It is easy to prepare it, low cost, length of 3 colors, it's portable, you can use it to see the day and the date. It can be used as a fan. This project needs a source energy for it to work. Follow the leg doesn't like constellate. Use source 5 BDC, USB, laptop, or PC. Conclusion. The Propeller Club is a club which is a show by and rotating bar of light emitting diode legs. The legs turn on and off at interval of the time, and the human eye is able to capture them sign. It is an optical sensor that has integration time of approximated 0.1 seconds. This phenomenon is known as persisting of vision, POV. The POV of the human eye has been used as a basic principle in this project. Next video.
Hi, this is Roger from Kanka Labs, and today I'm going to show you my just finished propeller clock. I was not sure if I should place this video in the Every Maker Should Have One video section, but I think most of us electronic nerds are also clock nerds when it comes to applications where interesting electronics concepts are used in a clock display. And I'm sure you already have seen on YouTube or anywhere else such propeller clocks. I always wanted to build one of my own in a globe shape, just to display the Earth globe and the time. But I simply don't find the time. So it was quite a happy incident that I think 3.5 years ago, Electro magazine published this Ulti-Prop or propeller clock. It was designed from one of the hobby electronics nerds on the Electro Labs forum or section. And finally, Electro made a kit out of it. We will discuss the details later, but I think first of all, let's turn off the light and step through the different display modes. You might see there's a little bit of jitter or wobble. That's simply because the propeller itself is not 100% centered, although I took every measure I could to give it a perfect centering, and it's also not 100% balanced, the two wings of the propeller, so there's still a little bit of improvement to be done, but I think it's already working now, and it looks worse on the camera than in real life, so if you go 1 meter away you don't notice the wobbling. So now let's turn off the light and see what other display modes we get here. So doesn't that look beautiful in the dark, except for the little wobbling? And the author or the constructor of this clock has integrated a lot of options, and I will go simply without any comments or without. Quite sophisticated. The author has managed to put all the functionality inside, and that it's really working very stable. Now power comes from with a 12-volt barrel connector. The whole circuit with all LEDs on takes about half an amp maximum. So we are at 6 watts maximum. You can see some switch mode power supply regulators. One is of course for the 5-volt digital section. Let's turn it on again, see if it works. It starts with 2 LEDs, then it starts in low brightness mode and then switches to full power. And of course, because now we have a white background, you can see it very well. But quite happy that I now have a partially self-made and not 100% balanced propeller clock. But for today, thanks for watching. If you liked it, please give it a big thumbs up and see you next time. Bye from Roger, bye from Kanka Labs.